I don't think anyone else is coming in. So this presentation is about the Esri Arcgis integration in HYPACK. I would say integration maybe is a strong term right now. It's mainly just file exports that Esri can load. So my name is Connor McDonald. I'm a programmer for HYPACK. I've been working here for 8 years. And I think there's some other things in here too that in HYPACK that we could export into Esri, but this is sort of just the stuff that I worked on for like the past year or so. So yeah, there's two objectives to the session. The first part is going to be my presentation, which is exporting compatible data from HYPACK. So exporting data from HYPACK in a format that you can load into Esri and do whatever you want to do with it there. If you want to process data or use their extensive capabilities that they have. And the three formats that I'm talking about today are just GeoTIFFs, XYZ files, and LAS files. I'm going to go into sort of like a technical definition of each one, tell you like what they are underlying, because I'm a programmer, so that's what I know. And then, yeah, the second part is I think we're going to do a demo with someone from Esri. So yeah, let's get on into it. So yeah, exporting compatible data from HYPACK. So first thing is GeoTIFFs. So TIFF stands for Tag Image File Format. And it's basically, not only is there a picture in there, they also have metadata. They have these tags that you can put in. And there's tons of different tags. There's tons of different specifications. And based on what the TIFF is being used for, you can embed a bunch of metadata. So yeah, and you'll see them as TIFF or TIF files. So GeoTIFF specifically is a standardized set of tags that allow a TIFF image to be georeferenced. So in this case, sometimes they'll have like a TFW file, right? Or you can actually just include that information inside of the file itself as one of these tags. So, and specifically in this case, the picture sort of is showing that. We take the geodesy information and projection information and we can embed that inside of the TIFF file. So, and then I wanted to talk about what a TFW file is, because I'm sure you've seen those before, paired with your TIFFs on export. At least in HYPACK, we do that a lot. And it just contains like 6 or so values, and it describes the location, the scale, and the rotation information. There's no projection information. It's just you load it in, and it just says, okay, this is where it is. This is what it's supposed to be scaled at. This is what it rotates into. So, and yeah, that can be embedded inside of the TFW. So the TFW will always have the same file name as a TIFF. So if you don't see a TFW, there's a good chance that it's just inside of it. So, yep. So there's a couple places that we export the GeoTIFFs. So I guess we'll talk about MBMax64 first. There is, if you're not familiar with MBMax64, the way that you set it up is that there's a matrix in the background, right? And you have multiple points in each of the cells. That translates pretty well to coming out as a image file, right? So there's an option called Save TIFF, and that just literally prints out whatever colors you have for each cell in there. It will just put it into that, into the TIFF file, and it will give you a TFW. So it will have the scale, the rotation, all that stuff, and the location. But that one does not have the embedded projection information. But then we have another option in there now, which is called Save Esri TIFF file. And instead of saving the colors, instead of saving like an image as colors, it saves the actual depth values inside of the picture. So instead of writing RGB like colors, it writes just a depth number. And Esri can look at that. There's a tag that says, oh, this isn't an RGB color, this is a 32-bit floating point value. And Esri will read that, and you have much more accurate data inside of that TIFF now, instead of just colors, right? So, but this is what I mainly worked on, was getting it embeds your HYPACK projection into it. So when you load it into ArcGIS, it should just say, oh, okay, this is the projection, and it will know what's inside of it, and it will know how to map it onto, whatever your map is, WGS84 or whatnot. So yeah, and in this case, with those files, because we're already writing so much metadata in there, I decided to not include a TFW. I just include that information inside of the file. So that should make things a little easier for you guys, I hope. So another place that we're exporting these GeoTIFFs is right outside of the survey program. So if you're in survey, you can go to your map window, and then there's a matrix dropdown. And one of the options is export to GeoTIFF, and John Marinuzzi actually made the interface for this. So, oh yeah, I already talked about the Esri TIFF files. They save depths instead of colors. So in this case, basically there's this little drop down here. I'm sure you can see it in well, you probably can't, it's really small. But in the bottom right corner, you can choose Esri TIFF file, or you can choose RGB color TIFF file. And it's just like I was saying before, where if you choose Esri TIFF file, it will save the depth values inside of the matrix. And if you choose RGB color TIFF, it will save just the colors inside of that TIFF file. And is basically just a copy of the code that I wrote. So it's the same way here, where these aren't going to generate a TFW file. So, and it will include your HYPACK projection information. So you don't have to worry about, when you load it in, Esri should just know, oh, okay, this is the projection this is in. You don't have to make a projection. You don't have to configure anything. Okay, so the next thing that we can do is XYZs. And I'm pretty sure, most software can just load an XYZ, right? So it's not that complicated. It's just essentially a text file with a list of three-dimensional points. It could be like a point cloud, or, so a high sweep thing, high sweep data basically in this case. But what we're doing specifically, at least for Esri, is they have these sort of like container folders, almost like a project file, right? And it's called a file geodatabase, and it's a Esri format. And it's essentially just a folder with a bunch of files with related data inside of it. And yeah, it can store, query, and manage both spatial and non-spatial data. So it's, it's a database. So currently we don't actually create a file geodatabase. You have to use one of the Esri software tools to do it. I think when I did it, I used ArcCatalog. It's not that difficult to set up. Yeah, you have to. So, oh yeah, and also the geodesy and projection information isn't transferred over because we didn't make the geodatabase. You have to do it there. So when you make it, you just have to make sure that it matches your project, your project geodesy in HYPACK. And if you do that, everything should be smooth and work out fine. So yeah, and also another thing that you have to do, or else you won't be able to actually take in the data, is you have to make a feature class that stores multi-point features with Z values, which is basically just saying it can store XYZ data in it. So yeah, and this is straight out of the shell. So if you go into your sorted data files drop down there in the little file tree thing. You can just right click it, and then there should be an option, export to file geodatabase. And you do have to have it checked for it to work. If it's not checked, it's not loaded. The data isn't actually loaded inside of the shell, right? Because if we were loading every single XYZ file, it would kind of get crazy and take up a lot of memory. But for large ones, like this is something I ran into is, you move the map, it takes forever to redraw everything. So what you have to do, well, what I would recommend doing is going into the settings in HYPACK and changing the, I think it's in the soundings, yeah. There's a sounding style, which is either it will draw the points as text or whatnot. And you should change that to pixel because it will just draw it as a dot, and that makes it draw way faster. You can draw a lot of points very, very quickly. So because it has to be checked, I would recommend doing that. So yeah, you right click the XYZ file, and then you just hit export to Esri file geodatabase. And you can see I have a dialog over there. It says select folder. We might change that up at some point, but for right now, that's what we have it as, because essentially the geodatabase.gdb it's like a folder, right? So it's a little weird. Like I'll probably try and make that a little nicer eventually, but for now, that's what we have. So you select the folder. Don't click into it. Just click the folder and hit OK. So then in here, you'll see this lists all the feature classes that are inside of that geodatabase. So once this pops up, you select the feature class that you created to store that XYZ data in. So in this case, it was multi-point 2. And you guys know the messages log in HYPACK? It's like in the bottom left corner, I think, by default. It will print out in there if it was successful. So it'll say export success. And if you see that, it should be good, hopefully. Okay, yeah, and so there's one more spot where you can do it too. You can do it straight out of cloud. So if you have data loaded into cloud, you can just hit File, Export, Esri Geodatabase, and it'll bring up this same thing. It will bring up the open file, select a folder dialog, then it will show all the feature classes, and you just hit OK. And yeah, should be as easy as that. So, okay. And then the last format that we can export is LAS files, and Esri can very easily take in LAS files. It's a binary file format designed to store LiDAR point cloud data, sorry. Yeah, and we can export to LAS from cloud and MBMax64. And yeah, Esri programs can load those files natively. So yeah, I mean, for me, that's pretty much it. I'm sorry, that's pretty short, but that's what we have for exported data. Does anyone have any questions for me about anything? Yeah, what's up? Oh, can you talk into the microphone? Sorry, just for recording purposes.
Hi, I was wondering if you can do the export from the tin editor.
Not right now, but we can add it. That's something that's nice about this stuff is like specifically the things I worked on, I tried to essentially put them into like a DLL or something so that we have shared code so that if someone wants something somewhere, just let us know, and it should be like fairly easy to just, it's essentially calling functions in a couple spots in the different code bases. So it should be pretty easy to just move around to anywhere that you guys want it. If you think of, that's the thing is like all this is new to us. So if you guys have anything that you think would be a good idea, like any programs that you think any of these features can be added to that would make your life easier, just let us know. And this should be really trivial to add to anything that we do. So any more questions? Yeah, can you talk in the microphone? I'm sorry. I know it's early.
If you set up the feature class geodatabase wrong with the projections, would it not say success? Would it say? wrong?
I think if it's not the right kind of feature class, it should have an error message. I worked on this, I think, like last year, so honestly, I'm not entirely sure. I don't entirely remember, but there definitely are error messages. The projection stuff, though, no, because if you think about the XYZ, right, that means that the XY is in just the grid that you're in. So it's not like you can put that in a wrong spot, really, right? You would just have to be careful and know what you're working on. And I'm assuming a lot of you guys like sort of work in the same areas all the time anyways, right? So you're not switching that stuff too much. So if you just have one in the right area, it shouldn't be too much of a problem. But again, this is something that we're trying to make easier. We're trying to look into making this easier for you guys to do, especially people that are mainly HYPACK users. So these are things that we're just going to have to keep working on, and eventually we'll be more robust in this area. So it just takes time. Any other questions? No? Okay. Well, thanks for having me. I guess we're going to move to the Esri presentation now. No.
Can you guys hear me okay?
All right.
Thanks. All right, let me just switch presentations here. Okay, thanks Connor, that was great, and I'm excited to play with some of those data sets myself directly out of HYPACK. Okay, so my name is Brian Connolly. I'm a solution engineer on the imagery and remote sensing team at Esri, so I play with a lot of the data sets that you guys create out of HYPACK. And so today I'm going to talk about kind of what's the next steps. What do you do with that data? But just first, kind of high level what Esri does, what GIS is, if you're not familiar with it. We kind of take a lot of content, whether it's XYZ data, whether it's LiDAR data, bathymetric data, imagery data, any kind of points, lines, polygon data sets. Bring that stuff into ArcGIS, and we could do stuff with it. We could do further analysis and modeling. We could visualize that data in different ways and do mapping, right? That's our bread and butter. And this leads us into doing more planning and design work. We can make decisions off that data and then take action, okay? And so in my world, in the imagery and remote sensing world, we kind of break this down into 5 key capabilities. And so I'll kind of talk about each of these capabilities a little bit in the context of what Connor presented. And I'll start with that content that's first delivered right out of HYPACK. And this is a big mess of a slide, but you'll notice some of those familiar things that Connor said, right? The XYZ data, the point cloud data, any of the imagery, those geotiffs. But it's a lot more. There's a lot of other data sets out there, whether it's unstructured, tabular type of data, 3D data sets, maybe real-time sensor feeds from IoT devices, multidimensional data. All of these types of data sets can be brought into ArcGIS, and then, like I said, do stuff with them. And why does this all matter? Well, today, you guys know this, we all have a ton of different types of sensors, whether they're coming off of aircraft or boats or drones or whatever they're coming off of these days. There's a new satellite going up every few days, it seems like. You gotta do something with all that content, and it really comes down to a few things, those capabilities that I was talking about, whether managing it, analyzing it, and sharing it out with either your clients, your customers, or even in-house with your own coworkers. And so what Esri does is that we take all of that and digest it into a simple management system so that you can deliver it into different clients, whether it's a desktop application or a web application, mobile devices, dashboards, and now we're getting into the world of simulations with game engines and all sorts of other cool things. So I'll talk a little bit more about those things. But the key thing here is really managing that data. So taking all of your data from all of your different projects that you've collected over a long period of time and organizing it, right? That's a very key step because you have to be able to search, discover that data set, do something with it, and find that stuff easily. So I test this to, a really good example is a drawer full of old pictures, right? Obviously today we don't really have that, it's all on our cell phones, but still it's a lot of imagery that's just sitting there in an unorganized state, and it's not useful. What we want is to be able to catalog that information into a nice picture book, right? And so that we could do stuff with it, like access it, query it, see the metadata, see that project information that's vital for decision making. And then we could do other things like further processing it, doing analysis, distributing it out, and sharing that data. And so a very specific example of using ArcGIS is our ArcGIS bathymetry solution. And this should be a little video, so let me get that played. Of course it doesn't play, I should have tested this out. Well, I could talk to it from here. What this really is a catalog of all of that information. You take your bathymetric surveys, you bring that in, you can filter on different surveys. So if you want to go back in time and visualize that, just imagine that that's playing and showing, going back in time and filtering on different surveys from different periods. You could take that information and visualize it easily within ArcGIS. And so a little bit more on what ArcGIS bathymetry is. It's an extension to add to ArcGIS with a bunch of tools and workflows for performing that type of visualization, search and discovery of different project data going back in time, and visualizing that metadata that's key to understand your information. One thing that it's not is it's not an acquisition software. It is not dot killing. It's not processing the raw sensor data. It's not doing that stuff. That's what we use HYPACK for. But then, to Connor's point, export out those files and then bring them into ArcGIS. I kind of touched on this, so we'll skip that. So next I want to talk a little bit about, okay, what's next? What do we do with that data? Well, we want to do further analysis, right? And so it's just some buzzwords that are out there these days, stuff like artificial intelligence, machine learning, deep learning, right? We could take all of those image files, the geotiffs, we could take the 3D data, or excuse me, the motion imagery data, the 3D data, and even text files, and then extract that information out into a really easy synthesized way. And the way AI and deep learning works is to kind of automate that and make that a little bit easier than manually clicking and defining that information yourself. And so there's an entire workflow, and I won't go through each step because it's a lot, but there's a key thing here, and it starts with this part here. So for an example, when we're taking imagery data in geotiff form or 3D data, and we need to extract out, say, a shipwreck from some bathymetric data, the process requires us to label and train that data set, right? So when, for example, when we are logging into a system and you have those little captchas at the bottom that say, identify the sidewalk or the street light, each one of us is training an AI model at that point, and none of us are getting paid for it. So what this process does is that entire thing. And in ArcGIS, you could do that. So you could take all of that data sets that Connor was talking about, whether it's bathymetry data or 3D data or whatever, and other type of things from satellite and drones. And with ArcGIS, we could take those and use some pre-trained models. So none of us are doing that labeling and identifying, different sidewalks or whatever else is in our data set. So we make these available for you and then make it a little bit easier to kind of extract that information. All right, and the last step here is visualizing it, right? So we have lots of different examples on how we can deliver data to whether it's a client or users in-house. And this could be anything. This could be some web applications. This could be for inspection workflows. This could be a dashboard that you could visualize some key indices about that data. It could be things for weather and wildfire tracking or flow dynamics, right? All of this type of stuff are just different ways of visualizing data within ArcGIS. Getting into the 3D world, another buzzword that's going out there are digital twins, if you've heard that. Really, it's just taking all of that data and putting it on a map and making it realistic so that somebody dives into it, they could actually see what's going on. So how do we do this? There's a few mechanisms that we provide to deliver different content. So you may have heard of things called story maps. Think of this as a way to present some kind of report in a web application. This way you can just send out a URL to somebody instead of a PDF document. Dashboards, kind of talked about this a little bit. This is that high-level picture so that you could visualize exactly what's going on. Think of, in the middle example there, a port may have a lot of information, whether it's wind information, weather information, sensor information. All of that could be fed in real time into these dashboards so that so a manager can see a high-level picture and just quickly make a decision based off of whether something's good or bad or not working, right? Then we have web applications, and you're all familiar with these. You play with web maps all the time, Google Maps and stuff like that. What we provide is to be able to take that to the next step and actually do something with it, right? So if I wanted to click on it and bring up a picture of that, an example of that tower there, we can visualize some drone imagery and see that. In the bottom right example there, you could see that I'm looking at an elevation data set there and drawing a little line, quickly getting an elevation profile, grabbing some statistics out of that information as well, maybe average height, average elevation, so on. And then also in the bathymetry example there on the left, we're just bringing all that content in. This way it's all accessible in one spot. It's kind of what Esri does. So picking up of what Connor was talking about, all those data sets that you can export out of HYPACK now directly feed into ArcGIS can easily be ingested, done something with it, and then analyzed and shared out. I don't have quite a demo here, but I think that is all I need to really go through. Any questions? If you have further questions, we're over here in the booth for the rest of the day, and I can show some better examples of maybe some data sets that might be up your alley.